Hello everyone! Today we are going to be talking about empirical and molecular formulas. The empirical formula is the simplest atomic ratio between the elements in a compound. It does not necessarily represent the actual numbers of the atoms present in the molecule, but just the ratio between those numbers. Just like C3H2 in a water molecule, they can't be simplified any further. To solve for the empirical formula, you first need to convert all percentages of each element in the compound to grams, pretending there is a 100-gram sample of each. This first step can be skipped if you do not have any percents given for the compound. Then, you will need to convert grams to moles using the molar mass of each element. After you've found the moles, you're going to make whole number ratios of each part of the compound by dividing the element with the smallest amount of moles by every amount. I'll show you what this is like in an example later. Lastly, using the whole number ratio you have of each element in the compound, write the empirical formula. Moving on from the empirical formula, the molecular formula consists of the actual numbers of atoms of each element that occur in the compound. In certain cases, it is possible for the molecular formula to also be its empirical formula, like H2O, but in most cases, it's just a multiple of its empirical formula. In order to determine the molecular formula, you need to first determine the molar mass of a compound's empirical formula, and then divide the molar mass by the molar mass of the molecular formula given. Lastly, multiply the new ratio by each of the elements in the empirical formula. Now, we are going to be looking at an example of finding the empirical molecular formula using the mass percent. In this example, we are using a sample that contains 40% carbon, 6.71% hydrogen, and 53.29% oxygen. We are also given the molar mass of the compound, which is 180.16 grams per mole. The first thing I like to do is separate the information from the question. Now, using the mass percent that we were given, we're going to pretend that there's a 100-gram sample of each of the elements in the compound and convert each of them to grams. With the grams, we're going to use the molar mass of each element to convert it to moles. Now, by using the moles of each element, we are going to determine which has the smallest amount. As you can see here, carbon and oxygen both have the smallest amount of moles, so we're going to divide each value by 3.33 moles to get a ratio. Now that we have the ratios of each element, we can find our empirical formula, CH2O. Now that we have the empirical formula, we can use a periodic table to figure out its molar mass, and now we can divide it by the molar mass of the compound we were given. This gives us a multiple of 6, turning our empirical formula to its molecular formula that we now know as hexose. Another way of determining the empirical formula of a compound is by using combustion analysis. In this example, we are told there is a combustion of a compound consisting of hydrogen and carbon that forms 13.75 grams of CO2 and 6.742 grams of H2O. Before we start this question, it is easiest to write out the combustion reaction of the unknown hydrocarbon. First, we need to find the number of moles of carbon and hydrogen in the compound. So let's start with 13.725 grams of carbon dioxide, and by using its molar mass, find the moles. Now, every molecule of CO2 contains one carbon atom, so we could say for each mole of CO2, there is 1 mole of carbon. Now the grams of CO2 cancel, and the moles of CO2 cancel, giving us the moles of carbon. Now by using 6.742 grams of H2O, we can find the moles of H2O using its molar mass. Now that we have the moles, we can say that the equation above shows that all the atoms of hydrogen in the compound are only in the H2O. So therefore, every mole of H2O produced is equal to 2 moles of hydrogen. Now just by canceling the grams of H2O and the moles of H2O, we're given the moles of hydrogen. Now that we have the moles of hydrogen and carbon, we can divide each by the smallest amount of moles, which happens to be 3.119 moles. This leaves there to be 1 mole of carbon and 2.4 moles of hydrogen. Now you may be thinking about what to do with the 2.4 moles of hydrogen, because it's not a whole number. Well, just by multiplying the numbers by the same multiple, you can make them whole. Typically, if you're giving any of the decimals on the right side, it is best to multiply the compound by these numbers to make it whole. In this case, our number has a 0.4 decimal, so we need to multiply our compound by 5 to make it a whole number. Now that we're given whole numbers, we have a complete empirical formula. Although the question seems incomplete, we actually don't have enough information to find the molecular formula, so it's okay to just leave it as is. Thanks for watching, and hopefully you learned about calculating empirical and molecular formulas. Bye!